Silakan, sudah bisa dimulai, Mbak.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. I wish you have a very pleasant day and serenity. Welcome to webinar held by Research Center for Telecommunication, Research and Innovation Agency of Indonesia, with topic Convergence of Communication and Artificial Intelligence through Cyber Physical System. I'm Christine Widyaningrum, and I'll be served as the host today. It's an honor to me to inform you that among us here we have distinguished the acting head of Research Center for Telecommunication BRIN, Bapak Dr. Nasrullah Army M.Eng, distinguished speaker Profesor Taufik Asihari, distinguished moderator Bapak Asif Aminullah Fatan PhD, and all participants and guests. Well, ladies and gentlemen, please allow me first to read the agenda for today's webinar. The first agenda is the opening session. Second, we will have presentation and discussion session led by our moderator. And last but not least, the closing session. Distinguished ladies and gentlemen, please allow me to read the webinar rule of conduct. Please mute your Zoom meeting. If you have any question, please type your brief question in the chat box and use the raise hand feature on the Zoom meeting. Please use the virtual background and all participants are welcome to change your name into name _ your institution. Alternatively, participants are able to join the webinar through YouTube BRIN Indonesia if there's not enough Zoom capacity. Before we process our first agenda, I would like to invite all participants to sing Indonesia National Anthem, Indonesia Raya. Gentlemen, now we are in the opening ceremony. As our first agenda, it's great honor to invite the acting head of Research Center for Telecommunication BRIN, Bapak Dr. Nasrullah Army M.Eng, to deliver for some welcome remark and open today's webinar officially. To Pak Nasrullah, the screen is yours.
Terima kasih, moderator. I am speaking in Indonesia, is it okay? Ya, Prof. Taufik. Pertama-tama terima kasih Prof. Taufik Asyari ya dari Monash University of Indonesia ya. Salam kenal Prof. Ya, ini pertama kali kita jumpa ya di forum webinar. Terima kasih sudah menyempatkan waktunya untuk hadir membagi ilmu dengan kami-kami sivitas mostly sivitas telekomunikasi, dan saya kira juga ada yang hadir dari luar gitu ya. Yang mudah-mudahan nanti terhitung amal jariah nih bagi Prof. Taufik ya. Sebagai informasi, jadi PR telekomunikasi, pusat riset telekomunikasi ini, Prof, jadi bagian dari organisasi riset elektronika dan informatika. Ya, jadi ada 7 pusat riset di bawah ORE ya, kami menyebutnya ORE. Jadi pusat riset telekomunikasi, sains data, ya, kemudian komputasi, kemudian kecerdasan artifisial, kemudian telekomunikasi, elektronika, dan mekatronika cerdas. Hampir semuanya home base-nya itu di Bandung. Ya, jadi kecuali satu itu pusat riset komputasi itu di Cibinong. Ya, jadi ada geoinformatika juga, tapi home base-nya juga di Bandung gitu ya. Nah, pusat riset telekomunikasi ini home base di Bandung punya kira-kira 60 preset ya. 60 preset terdiri dari prekayasa dan peneliti. Ya, jadi uh, mereka sebagian besar sedang studi S3 gitu ya, S3, dan ada sekitar 4-5 orang yang studi S2 gitu. Jadi targetnya lebih dari 50% sivitas kami ini mungkin dalam 3-4 tahun ke depan itu semuanya sebagian besar itu sudah PhD itu. Jadi makanya Pusat Riset Telekomunikasi ini mengencourage sivitasnya untuk studi lanjut gitu ya, baik di dalam maupun di luar negeri. Itu sebagai informasi dari kami, Prof. Taufik gitu ya. Jadi teman-teman, topik kali ini sebenarnya sangat relevan dengan rumah program kita ya. Jadi Prof. Taufik, kita punya pendanaan riset namanya rumah program gitu ya, dari PR Telekomunikasi. Itu telekomunikasi IoT gitu ya. Jadi saya kira sangat relevan gitu ya. Jadi topiknya kombinasi antara teknik atau teknologi telekomunikasi dengan AI gitu ya, yang mendukung pengembangan aplikasi-aplikasi apa seperti apa yang bau-baunya smart intelligent gitu ya. Jadi ada smart monitoring system, kemudian uh, intelligent sensing, kemudian aplikasi kebencanaan, smart apa otomasi industri gitu ya. Jadi ini saya kira cukup menarik gitu ya. Jadi uh, kebetulan gitu ya. Padahal tidak saya minta ini topiknya gitu ya. Tapi kebetulan relevan sekali dengan apa rumah program yang baru launching itu kemarin gitu sampai tanggal 15 September. Jadi mudah-mudahan teman-teman Sivitas uh, kayak telekomunikasi bisa memanfaatkan momen ini gitu ya. Dan sekali lagi terima kasih Prof. Taufik sudah berbagi, teman-teman yang sudah hadir. Ya, kita manfaatkan momentum webinar ini untuk terus menggali informasi dan memperkaya wawasan. Saya kira itu saja. Terima kasih. Selamat berwebinar. Assalamualaikum warahmatullahi wabarakatuh.
We would like to express our gratitude to Bapak Nasrullah, Head of Research Center for Telecommunication, for the welcome and opening remark. Ladies and gentlemen, before we begin our main agenda, now we will be taking picture together. So please, sir and madam, active the camera and video function of your Zoom application. I would like to invite the host to assist in taking picture. Please be prepared and wait a moment and hold in your best smile while our hosts are taking our picture. Okay. Okay, I will count. in slide 1. Okay. 1, 2, okay, please, open your camera. Yes. Okay, sebentar. Okay, I will count 1, 2, 3. Okay, slide 2. 1, 2, 3. Okay, I think we finished taking picture. Thank you for your cooperation. Ladies and gentlemen, we are now reached to our main agenda of the webinar. Before that, I would like to remind participants about the discussion session guide. Participants can ask questions through the chat box on Zoom meeting and or by activating the raise hand feature on the Zoom meeting. Participants can ask questions through the chat box and on YouTube. The moderator will present only selected questions to the speaker during the discussion session. Ladies and gentlemen, in this webinar, we will have presenter Professor Taufik Ashihari, and presentation and discussion will be presided over by Bapak Asif Aminullah Fatan PhD as the moderator. But before that, please allow me to read his CV. Bapak Asif Aminullah Fatan PhD is researcher at Research Center for Telecommunication BRIN, Education Bachelor Degree Electrical Engineering UGM, Master Degree Semiconductor Technology Asia University, and Doctoral Degree Electrical Engineering University of New South Wales. Work experience 2012 Integration Engineering, 2019 Lab Demonstration, 2021 until present International Research Fellow Electromagnetic Laboratory, Graduate School of Engineering, Nagoya Institute of Technology, and 2015 until present Researcher in Research Center for Telecommunication BRIN. Ladies and gentlemen, let's welcome our moderator Bapak Asif Aminullah Fatan PhD.
Okay, thank you so much, Ms. Christine, and welcome to our webinar for all participants today, and I'm glad to have you all here. So, as mentioned by Dr. Ruli, Masrul Amri, this webinar is conducted by the Research Center for Telecommunication BRIN, and it is the 5th webinar in our series this year. Okay, so in this session, we'll be exploring some of topics that I believe familiar with you. So we will talk about communication technologies, artificial intelligence, and new things called cyber physical systems. And I think this is the main topic. Cyber physical system is a new topic that is creating new possibilities in various fields, including IoT and also smart cities and other applications. So yeah, and the title, as mentioned previously, the title of our webinar today is, let me just check here. Okay, so the title of our webinar today is Convergence of Communications and Artificial Intelligence through Cyber Physical Systems. So, and we are fortunate to have a knowledgeable speaker today with us today, who will share his insights and experience on this important topic. So first, I'd like to introduce our speaker, Professor Taufik Ashihari. So Professor Taufik Ashihari is a professor of data science at Monash University, Indonesia, and a visiting professor of future communication systems at Birmingham City University, UK. He received a PhD degree in information engineering from the University of Cambridge, UK in 2012, and Bachelor of Engineering with honors
degree in electrical and electronic engineering from Nanyang Technological University, Singapore in 2007. He has developed an international reputation for his research work in information theory, communications, signal processing, smart sensing, and machine learning for next generation cyber physical systems, as evidenced by publications of more than 80 peer-reviewed articles in the world leading journals and conferences. He has a track record of winning and leading competitive research grants, fellowships, and awards, most notably Best Research with Public and Third Sector, EPSRC Global Challenge Grant, Samsung GRO Research Award, IEEE Euroship Best Paper Award, NSC Taiwan Grant, RSIM Alain Bensoussan Fellowship, and Cambridge Trust PhD Research Scholarships. Professor Ashari has served as research lead for the 10 million pound 5G connected forest, looking at how 5G communication can realize the wireless service of high definition contents in forest areas. I think he's also, so the point is he has many research projects experience. And also he has served as academic editor in various journals, including PeerJ Computer Science, Topic Editors of Sensors, Associate Editor of Elsevier, GKSU Engineering Science, and Associate Editor of IEEE Access. So Professor Ashari has also served as the board of experts in environmental and computing and at Wallacea Research Center for Biodiversity Conservation and Climate Change. And he previously held full-time visiting professor with Coventry University, UK, Cranfield University, UK, National Chao-Ting University, Taiwan, Nokia Bell Laboratories, and University of Stuttgart, Germany. And Professor Ashari is also a senior member of IEEE Fellow and Fellow of HEA, and is affiliated with Isaac Newton Institute for Mathematics Science, Cambridge. Okay, with that, I will handle it to Professor Taufik. So, can you hear me, Professor Taufik?
Yes.
Okay, so please, your time is 45 minutes for presentation, and after that we'll have discussions. And for audience, so this presentation will be in English, but if you feel difficulty in asking question in English, so no problem, you can ask in Indonesian. Okay, please, the screen is for you.
Okay, thank you very much, Asif. Can you see all my screen?
Yes, I can see it. Yeah.
Okay, yes, see it. That's great. That's great. Okay, thank you. Thank you, everyone. Good morning, everyone. Thank you for the invitations, Pak Nasrullah, Pak Asif, for this very good opportunity to actually. This is my first time to speak in the context of a BRIN research center. So I think I was actually looking forward to it, and hopefully there could be avenues of opportunities which we can follow up and explore it together, perhaps after this talk and perhaps after a couple of activities after this event today. Right. So my talk for today is I'm actually going to share with you a kind of experience which I was involved in. I think there was actually an introduction about myself. My background was actually electrical engineering with a specialization on infocom, and then you can call it a destiny or fate, but I was actually switching to a little bit more on the theoretical side, information theory during my PhD. And then I built my academic and research career overseas, and there has been a lot of I would say pressure and demand as well in terms of securing some funding, and I found throughout my journey that it was actually quite difficult to really focus on the information theory and communication technology in particular. So I kind of trying to explore a little more fields outside of that, and that actually brings me to the field of cyber physical system, which I'm quite happy with because it allows me to combine the good side between what we develop in communications and how we can utilize in artificial intelligence, especially given the fact that there has been a lot of hypes and development over the past decades on the AI. In particular, we see emerging trends around reinforcement learning, around generative AI nowadays. So even like some of the big questions in communications, people are starting to rely on AI to actually to give like a certain answer. Okay. Uh, I'm going to actually share with you um, the context application scenario, which is actually driven by the needs rather than by the technology. So as you can see later that I have been working with people across different domains and working with those people actually shape the interests, shape a lot of other problem, I would say, that we actually find in between the integrations between AI and communication. Okay. Okay. Yeah, sure. So I think this is like my background. I think Asif has introduced this to you all, so I'm not going to repeat this, but I'm going to put two highlights that I was actually leading like one of very big projects in the UK, starting from the 2020 to 2023, just before I returned to Indonesia, and that was like a project where we try to explore the utilization of 5G in rural context in forestry areas. Obviously, we know that when telecom operators are moving from 4G to 5G, it's not just simply changing the number from 4 to 5, right? It's also like the implication is huge actually because we know that 4G has a relatively large tower to cover certain area size within the populations, but 5G cell coverage is actually much smaller than 4G. And that creates a lot of issues because when we look at the installation of base stations, then in order to produce the same level of coverage, we need to have much more base stations compared to 4G. And the UK government, back in the late 2020s, I think they are thinking about expanding their 5G coverage because pretty much like the 5G coverage is available within the urban area because that's where the economy is all about. That's where like majority of the population's relying on the services. So they start thinking whether we can actually expand the coverage from from urban area to rural area. And in order to do that is they need to know whether the investment, because we think that infrastructure development is an investment, right? Whether the investment will pay off the price or not. And part of that is they are looking at the different use cases, ranging from agriculture, ranging from environmental management, such as forestry, also like industrial setup, which is happening in rural area, tourism, and so on and so forth. So there are actually a number of projects being funded around 2020, and we actually reported back to the UK government to see whether the investment will be feasible enough or not for the deployment of 5G in rural areas. So this is one thing. The other thing is I was actually involved just before I was actually returning to Indonesia a year ago. So just before returning to Indonesia, we actually received a good news that one of the proposal about putting some digital enabled healthcare was actually successful, and I had to actually continue in co-leading that project. So this is actually a project funded by Innovate UK, and we are looking at how we can utilize the benefits of future digital technology, including 5G and potentially 6G, in order to help developing products that will be relevant to the healthcare sector. So we're working with, I think, about 16 members of the consortium, ranging from universities, SMEs, investment, I think investment bank. So because we want like part of the idea of this consortium is to create like products which hopefully appeal to the market. And in order to bring that to the market is we need like investors. So that's why in the consortium we have this investment bank helping the SMEs to develop the product and measure the visibility of product. So these are the main two things of my activities over the past 4 or 5 years, and some of these are still continuing. Some of these are actually opening some of the opportunity which I currently have in the context of Indonesia. Okay, I'm not going to give a lot of intro about Monash. I think one thing that I'm going to say here that we are one of the early foreign university established in Indonesia. So we are looking forward to working with Indonesian stakeholders. So pretty much we welcome collaborations with BRIN, with other research institutions as well. And our mission is very clear, is to contribute to the further success of Indonesia. So that's the reasons why we set up the campus here. We have a range of activities, a range of research hubs, which are actually established in the country. So it's not like we are just relying on the centers that are available in Melbourne, but we also create something that is actually dedicated for Indonesia. Okay, this is like I think Indonesian campus is the latest international campus of Monash. We have presence in Malaysia. So presence in Malaysia is about 25 years ish. And then we also have presence in China, working with the Southeast or Southwest University. I forgot exactly the name, but we work in Suzhou. We also have collaborations with IIT Bombay to set up Monash Graduate Academy in Mumbai, India. So focusing on PhD degree only. And then we also have a center in Prato, Italy, which hopefully will help us in accessing some funding from European Union, like Horizon Europe, for example. Okay, in addition to that, I was actually living like a very, very large team actually in Birmingham. So my last employer in overseas before returning back to Indonesia is Birmingham City University. I built actually a Future Information Networks Research Cluster, which is part of the Cyber Physical System Research Group. In the starting point, we start with only 2 people, but before I left, we have like 12 or 15 members of the cluster. And in the cluster, we also have, through the research projects, we are able to purchase like a 5G private networks. So we have our own base stations along with the server, along with the connectivity which we want, and we utilize that for various multi-domain use cases testing. So we have seen interest from people across different areas such as healthcare, and then we also have been approached by people from the one that is doing like live streaming for Paris Olympic. We also have been approached by people who are actually doing monitoring along the highway road. So there has been actually a lot of use cases, and I think the value of the technology lies on those use cases, because we think often like when we think as engineers or scientists, we just think about the technology, right? We forgot about how the technology can bring values. But when we think about the impact, then the value is as equally important as the technology itself. So for example, like 5G or 6G will not be game changers without incorporating applications that are also game changer as well. So, like nowadays, like the technology we have, if we just use it for our own day-to-day tasks, such as watching video or receiving this information, the current technology is enough, right? We don't need to have something significantly upgraded, perhaps to 5G and beyond or 6G. So, in order to us to adopt those advanced technology, it will make sense if we have some applications that is also game-changing, that is only possible through that technology. So we thought that application then is actually quite difficult to convince various stakeholders for technology adoption. So that's why I think you may observe that the 5G rollout and deployment is not as exciting, I would say, compared to 4G, because I think based on my various conversation and observations, the game-changing application is not quite requiring that level of technical capability. So in that case, perhaps like with the current technology, it's more than enough. Yeah. But let me tell you a bit more story about this later on when we talk about some of the trials we did with the 5G, etc. Okay, so this is like a kind of my research profile. So as I mentioned earlier, I was trained as information scientist, information theorist in particular, and then in that particular domain, I was working on coding theory and as well as data processing. And then the context of cyber physical system and computational intelligence helped me to put this information theory expertise to an applications which otherwise is not possible. So you can see actually the cyber physical system here is acting as interface between my scientific and theoretical knowledge to the possible impactful applications which I can possibly have with those theoretical knowledge. And this research has been actually developing quite a lot over the past, let me recall, maybe about 10 years or so, and it's been sponsored, and we actually have a wide range of collaborators from universities, industries, and so on and so forth. So we are not just working for the sake of technical development, but also working how the technology can actually make impact to industry or to the society in general. Here I put some little notes. So actually, I was part of like maybe small group of academic researchers back in 2014 or 15, I think, which pioneers like the work on error correction codings, and that error correction coding was applied to the new area of communications, which we call it as molecular communications. I'm not sure whether in your research center you have someone who is actually interested or has done something around the molecular communications, but this was actually one of the earlier work, I would say. I stopped this research for the reasons that there are actually more projects that I have to take care of, but I'm always interested in reviving my interest around this area, and I can, if any one of you will be interested around this, I will be happy to have a further conversation how we can actually set this up, because I will say that the impact of this molecular communications will not be happening tomorrow or 1 year from now or 10 years from now. I think it will happen in perhaps 100 years from now, because the field itself was just initiated in, I think, 2010, I think. There has been a lot of development around people in Osaka, Warwick, and York in Canada. So I think at that time it was like a very small circle of academic researchers, and then the circle was actually developing, and it becomes a little bit more interesting nowadays. But still, this area seems to have high risk in terms of research investment. So I think one of the issues in pursuing this research is, especially I'm talking in the language of the UK and Europe, is around the research funding. So that's why like a lot of those people, they are actually switching to slightly different. So I know like my ex-colleague, he used to be one of the earlier adopter of these research directions, but then he changed his interest to something quite different. So, but I think this area will make impact in the next maybe 100 years or so, when the technology is being matured and a lot of interest around developing communications at a nanoscale. Yeah. Okay. Some media coverage. I'm not going to talk about this, so let's just skip. So I'm going to talk more about this kind of arrangement. So I'm trying to convince you that knowing like a theoretical knowledge, theoretical understanding of communication system reflected by information theory is very helpful. Provide us with flexibility and freedom to explore areas which might not be our initial focus. So, for example, here I can actually try to to see how this information theory can be applied across wireless communications, which has intersection with cyber physical system, and also has intersection with computational intelligence, which is the backbone of the today's artificial intelligence. Okay, so obviously when we talk about cyber physical system, sometimes people associate that with Internet of Things. They are not totally wrong, I would say. The terminology of CPS and IoT, they are pretty much organic. There is no one actually making like very generic descriptions at the beginning. So what happened here is that it came from wireless sensor network, right? Wireless sensor networks was actually quite popular around starting from 2005 to 2010, I think. And then because they are looking at the capability of sensing, they see the capability that the data from sensor can actually be transmitted directly, providing complete or comprehensive observations of certain phenomena. Then they start thinking that perhaps, okay, all of these different sensing devices can be put together, can be interconnected. There could be like network of sensing devices, and and that actually translate into IoT. And then when we talk about CPS, there is an element of cyber, which is more like abstract, which is the opposite of physical space. And then when we actually put together the cyber and physical together, we start seeing some emerging possibilities. For example, we can have some intelligence being put not just on the communication devices, but also on the cloud, right? So we can see like a collaborations between computing devices that are closer to the interface and the powerful computing facilities like the cloud. So we have like a cloud and edge computing. But then the implication is massive. We can see a lot of applications in smart cities, as Asif mentioned earlier, smart agriculture, precision healthcare, and so on and so forth. Yeah. So I will say that within this talk, I'm not trying to make a distinction between the two. So these two can actually work hand in hand. But I think if you look at some of the discussions online and offline, this is like the discussions from Huawei forum, I think. So they try to make a distinction between CPS and IoT. So they say that IoT is pretty much more like a networking of sensing devices. Okay, so you put like sensors, and then you have like a gateway. You have technology like LoRa, NB-IoT, LTE-M, and so on and so forth. And then when you have this collection of sensors, then you call it as IoT. On the other hand, the CPS is much more like broader than IoT. So CPS encompasses not just the networking of sensing devices, but also the cyberspace of the application. Okay, so for CPS, we are not just focused on the interconnectivity, but also on the computations, on applying data-driven models to analyze the data directly, applying models to combine data from multimodal devices, from sensors, from cameras, from data that are generated by human being, allowing much more smoother interactions between human and physical space. So I think the reasons why I use the cyber physical system in my talk is based on my perceptions. I would say that CPS represent much more broader terminology where the physical and the cyber space integrate with each other. So that's the only reason. Yeah, but the distinction is not too clear, and they can always represent one side over the other. You can actually look at the discussion, the analysis done by the National Institute of Standards and Technology, and they have a lot of sort of like findings from the literature, how these two terminologies start appearing and how people taking research directions based on CPS terminology and IoT terminology. So if you are interested in this discussion, I will recommend you to look at this reference. Okay, I think the key idea of cyber physical system is these four entities, and this is actually coming from Cisco. Yeah, they call it Internet of Everything. But I would refer this as something that define cyber physical space. So in these entities, we have people, us, we generate data, we use technology, we are getting benefit of receiving data from users, from machines. We also have what we call as things. So things represent machine that produce data. So things can be sensing devices, things can be cameras, things can be sensing devices along with some computational capability. It can also represent collections of sensing and actuating devices within, let's say, self-driving cars, and so on and so forth. Yeah. So anything that is represent some objects, we can call it as things. The common things between people and things, they are both producing data. And those data being produced will help to improve the process, how we deliver the right informations to the right persons at the right time. Okay, maybe just a quick, introductions for those who may not be in the AI domain. So I think in AI we have pretty much algorithm, concept, techniques, but the major application of AI rely on the two things. The first thing is what we call as supervised learning. Okay, supervised learning. So supervised learning, the very first example of that will be learning based on a data set that is known. Okay, for example, like in this case, we have very simple illustrations where we have a machine. We want the machines to identify that this figure is a monkey. Okay, and then we want this machine to say that this figure is a cat, and we want to ask this machine to learn that this figure is a dog. Okay, so what we do with this machine is we throw a lot of data with those labels. Okay, so we call it labeled data. So that's why the name is supervised learning. And upon learning a huge instances of those data along with the label, the machine pick up knowledge. So whenever like the new thing being presented to this machine, it can make certain decision. Yeah. So let's say if this machine is being put a picture like this, which may not be in the data set, then the machine can tell that this image is actually a cat. Yeah. So this is a very simple example of machine learning. In the context of, like human learning, we learn this like when we are at the early stage of our education, right? We learn like a letter A, for example. We were told by our teacher that this is A, okay, or A, or B, and so on and so forth. And we actually pick up the knowledge that a shape like that should read A. And then based on that knowledge, we make a lot of inference. So obviously, if A is written slightly different, we can still make decision that letter is still A. Yeah. So it's a similar thing, like what happened in machine. And obviously, like when we talk about communications, we can apply this to wide range of contexts, including the design of error correction code. So one of my former mentor in Stuttgart actually utilizing this type of supervised learning using neural network to develop the error correction code. So rather than doing like typical calculations or design of codes to mitigate certain errors, they utilize the AI. Okay, and they have applied that in the library setup. And it's not just like conceptual, it's not just simulation, but they also apply on the real devices. Yeah. The other example of AI is what we call as regression, and this is actually quite useful. For example, like when we are trying to predict like network latency. So what we do is we look at what happened in the previous days. So let's say today's latency and yesterday's latency and so on and so forth. And based upon those data, maybe we can predict what kind of latency will happen tomorrow. And this can help in a lot of applications, right? For example, applications that are quite sensitive against delay. So they may want to predict the delay beforehand so they can optimize the resources so that the delay can be minimized. Yeah. Okay, so that's all about the overview of AI. I'm not going to talk AI in more details, just like a snapshot, I will say, of the world of AI. And then if we look at how AI can present, we obviously can look at the evolutions of communication technology. So we have 1G, obviously, just call maybe little bit of text. And then we have 2G, where the text is quite dominant and emerging. And then we have 3G, where we start looking at the applications, video-based applications, and so on, multimedia content, and so on and so forth. 4G, the application is getting more and more immersive, more and more rich in terms of content. We also start seeing things that rely on the connectivity to allow people playing interactive content such as games and so on and so forth. And then we have 5G, where things will become more and more ubiquitous, more and more autonomous in the context of providing the connectivity to low latency control system, providing the connectivity to a large number of connecting items, and so on and so forth. Okay, so if we zoom in, like the level of communication we might have with those evolutions, we start seeing things that are happening like micro level. So an example for that will be cellular system or satellite communications, but we also see things that are actually happening on the micro level, such as the applications of this Internet of Nano Things, which is facilitated by molecular communication. So something that is happening inside like the body, and we try to engineer certain possibility of exchanging information, not using electromagnetic, not using radio signals, but utilizing like molecules. Okay, so if you look at this, I think perhaps for all of you who work on this area, I think this type of graph is quite familiar. So we see that the explosions of data requirement from the past 1 decade or so, and the thing is that most of the data will be dominated by smartphones, right? So obviously that means that the connectivity requirement will be more and more higher. The mobility requirement will be more and more stringent. And when we talk about increasing number of users, then obviously we need something that can facilitate that. But unfortunately, if you look at our resources, the wireless resources, the spectrum, they are actually limited resources, right? So obviously things are evolving, new spectrum is being introduced. Some old spectrums perhaps could be utilized in the framework of, let's say, cognitive radio. So there are a lot of things that people are looking at how the future technology can address these data challenges. Okay, so just a quick intro about information theory. I think some of you, I believe, especially those working on communication system, modulation, coding. I think you should be familiar with this. I think so. Information theory is a theory to measure and quantify informations. If you came across bits, so bits was actually coming from from the concept that was outlined by Shannon. So Shannon is the father of information theory. And that allow us to characterize the information transmission, that characterize on introducing techniques, coding schemes, architecture that can achieve the capacity of a given channel. So information theory is quite different from the typical communication research that are dependent on technology. So rather than focusing on specific technology, information theory is trying to represent communication entities using abstract concept. Okay, and that is aligning with what Shannon mentioned, that the problem actually, the fundamental problem of communication is to reproduce at one point exactly or approximately a message selected at another point. So this is the focus, and we don't really quite care about the specific devices we use, whether it's IoT, whether it is satellite communications. What we care is how we can represent those entities as probabilistic transformation, and then we can develop like mathematical tools to solve the problem, right? And there are two things in information theory. One is data compressions, how we can compress the data as much as we can so that the data will be represented in much more efficient way. And we have this terminology called entropy in the context of data compression. In the context of digital transmissions, we have the channel capacity. This is quite widely used term for people working in communications to characterize the ultimate limit of data communication in which the reliable transmission can be guaranteed. Yeah, transmission that achieve probability of error to be as small as possible. Okay, so in that case, we are not really looking at the specific technology, but we are looking at the abstraction. So that's why, like, if you can see, like, the profiles of what I did in the past, I can sort of like moving between wireless, molecules, and so on and so forth. The reasons of that possibility is because I'm not working on the specific technology, I'm working more on the abstraction of that technology. So for me, I think if I can represent the behavior of the communications utilizing the probability function, let's say, everything should be possible in terms of the analysis. So it's less dependent on the technology we use. So we can call it like technology agnostic. Yeah. Okay, so when we look at the concept of the capacity, we look at the concept of mutual information, and then I think the easy way to look at the capacity is looking at a pipe, water pipe. Yeah. So if you look at the water pipe, you put in water with low intensity, the water can flow smoothly towards the end of the pipe, right? But when you add the pressure or the intensity to the pipe, as soon as it hits the maximum capacity, the pipe will not be able to accommodate the water, right? The water will just, going out, and there is no possibility to putting more pressure to the pipe. So when the pipe reach a limit where it's close to break down, let's say, that is what we call as the capacity. So we can think channel capacity as that pipe capacity, and that is coming from mathematical tools called mutual information. And this is actually my interface with the domain of AI, because it turns out that the mutual information is being applied a lot in machine learning. For example, when try to measure the dependency between the two variables, they can utilize mutual information. When they try to measure how significant one parameters over one target label, they use mutual information. So we can see mutual information is a kind of correlation tool, and that help us in the context of communication to characterize channel capacity, but in the context of AI, it helps us to carry out a lot of machine learning tasks by relying on the mutual information calculation. Okay, now I have just give like some outlines on the information theory and the context in general. So I'm going to a little bit more specific with the practical realizations of those things. So when we look at the applications of information theory in understanding what the future of the communication system can look like, then we can look at some of the white paper that was published by one of the big tech company. For example, like Samsung. So Samsung has this white paper on 5G and beyond technology. They came out with different sort of like approaches. For example, things from cell-based communications, different types of macro and micro cell, and how they can coexist together. And they also look at what kind of technology that can be developed at the user end, how the mobility can be handled, and so on and so forth. So these are a number of things. For example, like you can see there are a lot of research around millimeter wave. There are a lot of research around cellular IoT, particularly the evolutions from NB-IoT to LTE-M. There are also research around advanced MIMO, such as like massive MIMO. I used to work on massive MIMO for a number of years, but then I switched to another interest. And then also like small cells, and this is quite relevant to the concept of 5G, where we'll have like smaller base stations, but those base stations will be allowed to cover the same level of area within the population. Okay, so I think when we look at different technologies, we may be confused, but actually, when we look at the guidance provided by information theory, we can look at the typical Shannon formula, right? So this is what we have, right? In Shannon formula, we have something like log 1 plus signal to interference plus noise ratio. So when we look at this type of formula, we can identify what we can do to help address the challenges of data pressure. The first thing we can do is, here is the number of access point. Okay, this is actually aligning with the idea that the 5G needs to have like multiple base stations. So we increase the number of access points. B, the bandwidth. Obviously, the more the bandwidth is, we can serve more data rates. M is the number of antennas. So this is like simplification, obviously, because MIMO capacity will not look like this, but this is a simplification. We can increase the number of we can increase the channel capacity by increasing the number of antennas. So that's why like the research in massive MIMO is quite important, because it is something to do with the increasing number of antennas. And then finally, we have the term that is inside the lock. So it's SINR, signal plus signal to signal plus signal interference and noise ratio. Okay, signal to interference plus noise ratio. And you know, techniques that can help to develop that is techniques along the interference suppression. When we talk about NOMA, OMA, comparison with OMA, and so on and so forth, that is actually belonging to the case where we want to reduce the interference, but at the same time we want to also maximize the multiplexing capability within the network. Okay, so this is just you know, an example of how these massive antennas can be utilized. So obviously, when we borrow the idea from information theory, we can analyze the capacity regions of this channel. We look at the diversity and multiplexing trade-off. But obviously, we have to also be sensitive against the mobility issues, which can introduce rapid channel fluctuation. So channel estimation can be quite challenging, because not only about the mobility, but also the number of the pair of the channel that needs to be estimated between users and the base station. Okay, so when we talk about the massive MIMO, the order of the size of the antenna at the base station is around 100 to 2000, quite huge, and the order of the user is like 16 to 64. So if we talk about typical like orthogonal pilot channel-based channel estimations, that orthogonality requires reservation of orthogonal resources. So orthogonal resources can be time slot, or it can be frequency slot, of the same order as the number of antennas. So if you talk about having like orthogonal pilots in the context of massive MIMO, then we need to have pilots to be around this scale, which is quite huge, because you end up transmitting more pilots and less data, right? And this is something that we really want to actually avoid. And one possibility to do that is by looking at what we call as simultaneous transmissions of pilot and data, and we call it like a superimposed pilot strategy. And we can see actually the benefits of having superimposed pilots. So, for example, here we have like a curve where we have the achievable rate is a kind of capacity, and then we have the Doppler bandwidth, which denotes the mobility speed of the terminals. We can see that as we increases the mobility speed, we have higher Doppler effects, right? So in that case, we say that actually the orthogonal pilot, OP here, is going to break down after a certain level of mobility, because simply the number of antenna is too much to be estimated by rapid fluctuations of the channel. Whereas when we talk about the superimposed pilot, where the data and pilot can coexist, they are actually quite they are decreasing, obviously, because of the higher mobility requirement, but they are not breaking down quite easily. Yeah, so they are maintaining the ability to operate even after certain Doppler frequency. So when we talk about the potential in the context of end user requirement, then we can talk about the applications around high-speed train. So which will introducing certain Doppler effect, and that is beyond the typical Doppler effect, which is supported by majority of values in the current standard, I think 3GPP standard. Yeah, so that's why like this superimposed pilot will offer something quite unique and something quite maybe like serving as an alternative to the status quo, the orthogonal pilots. Okay, so obviously from those, let's say an example of channel capacity analysis with the technology that we put to help addressing the data challenges, we can We can look at various tools which we can utilize to address the other requirements. For example, the other requirements could be not just channel capacity, but also the latency. When we talk about the latency, then we talk about finite data length, right? One thing that people not realize when we talk about the capacity is we are actually transmitting very large code word, okay? Code word of having quite large dimension in representing the message. But obviously, that kind of analysis should not be applicable directly to the context of finite block length, because finite block length has a fixed delay, has a fixed number of channel outputs to represent the message. So in this case, the capacity will no longer be an appropriate tool to characterize the transmission. Okay, so the other things will be on the enabling the communication protocols and also like multiple access. So like what we talk about the setup, which we explained earlier about Massimo, that is pretty much like like one way of transmission, downlink or uplink, right? But when we talk about the multiple access, the difficulty is not just around the synchronizing the number of transmissions, but also looking at transmission that is not synchronized. So users may not always have data to transmit. Users may have a certain pattern in generating the data, and that will create like a certain different contentions to the channel. Okay, so some of the applications which we do here, I was actually collaborating with Telkom University back in 2017 is on applying some of these techniques and doing some simulations on IoT enabled disaster monitoring and recovery systems. We are actually simulating the multiple access point of the channel. So we're looking at analyzing the collision probability. We are looking at deriving the optimal throughput by adopting the combinations between massive number of antennas and the error correction coding. Yeah. Okay, so one of the things that we also accommodate within the project is we're looking at the AI or intelligence-based applications where we develop collaborative search algorithms and how that collaborations can be enabled through the network connectivity as we define by utilizing the error correction code. Yeah. The other thing that I want to maybe talk a bit more here is my projects on 5G connected forests. So this was actually quite ambitious projects. We have like ambitions to be like maybe one of the world first 5G connected forests. We did this trial in one of the forests in the UK. So if you know Robin Hood, the forest that which we did the trial was actually the forest that believed to be the place where Robin Hood was based on. And the focus of the research which we do here is on the environmental management. So obviously, when we do environmental management, we look at the data that can be captured by devices such as drone and robots, and how we can process this data quickly, close to real time, and make certain decisions based on the data being gathered. Yeah. And when we look at this trial at the beginning, we are focusing on this 5G band here, 3.4 to 3.8. If you look at the location of the band, they are actually quite close to the Wi-Fi, right? So this close proximity inspired us to write one of the papers, and it was published in Transaction on Vehicular Technology. And it allowed us to actually construct a scenario where maybe the 5G and Wi-Fi can coexist, and what kind of implications we can actually gather by looking at the close proximity between the Wi-Fi and 5G. Obviously, we didn't do the actual trial for that conceptual proposal, but we did a lot of experiments and field-based findings on the technology itself for different purposes. Yeah, for different purposes. So this is like the network. As you can see, it's not too big, right? This is the 5G private network, we say. It's not too big. It costs quite a lot, actually. I think perhaps around 1 to 1.5 million, I think, pounds, I think. We have like network operator, which we work together quite closely to give this installation, to give us like the SIM card to access the network. And obviously this network will be shared between different applications such as drone, robotic, and also augmented reality. Yeah, so in addition to the environmental use case we have, there are also use cases like AR, VR, and the usages where it requires a lot of high definitions data as well. So really, like we are testing the capability of this network to support all of these use cases together. Okay, so in terms of the environmental management, we're looking at the case of the forest. Obviously, in the forest, we don't have a lot of connectivity, even for 4G, and we know that the 5G is quite limited in coverage. So we are looking at possible different scenarios where we can leverage the collaborations between the existing status quo connectivity, such as maybe 4G, maybe not much, but at least we still have some connectivity there. And also, technology from Wi-Fi, short-range communications, and then the data aggregator, which can be facilitated by 5G. So in this case, we have like variety of the data capture of interest, and then we look at what possible technology that can be utilized, and then towards the end, we do kind of aggregations on one of the UAV, and that UAV will send like the aggregated data, which is of high definitions, which is of high data rates to the base stations, to the powerful computing facilities, based on the aggregated multimodal data from the environment. Yeah. So we did some testing on the behavior of the network. So we see that here the one on the top is the 5G connectivity. Obviously, 5G promised us to have a latency of 1 millisecond or sub millisecond. The technology we have at that time, it was approaching like 4. Like this is like the best we can achieve in practice. If you compare with 4G, 4G has like 7, the best. So it's like half or like a third better than 4G in average. Yeah. So this is the practical measurement. So it's not something just simulations or conceptual, but something that we obtain from the field, from the forest itself. What is the implication of this? The implication for this is for us to be able to know the limitations of the network when we define the use cases for each of these data capture. Because some of these could be related to mission critical application, like detecting disaster or detecting missing person, right? So in that case, the lower latency we have is the better. Latency is also useful when we talk about machine learning, because realize it or not, a lot of our programming tools like Python or or any other type of programming languages, they rely on libraries, right? When we implement, let's say, TensorFlow, they rely on libraries, and some of these libraries are actually located remotely. Yeah. So if we rely too much on those remote locations of library, then obviously some of the data capture, some of the computation which we want to incorporate here will not be possible. So we have to do something quite innovative here, something quite tailored against the application requirement. So that's why we need to know exactly like where the latency is and how we can leverage that information to design our application oriented better. Okay, so with that particular problems, we came up with a lot of sort of like challenges, and the good thing with challenges is we are able to produce a lot of knowledge from the analysis. So we look at the ability to actually rely on multiple computing infrastructure. One is close to the UAV, one is close to the cloud, and how these two can actually collaborate with each other to perform like calculation. So in that case, connectivity is one important thing, but also the power of the edge devices is also another consideration. So what we don't want is we deploy some complex model, some complex computations, but that will exhaust the battery on top of the battery requirement for transmission. So we have carried out a lot of like a different aspect of the research, from the task length optimizations, from optimizing the battery, from mitigating the missing data, and so on and so forth. Yeah. And this is something that we can utilize, like the tools from information theory, for example, to formulate how we can actually relate between rate, power requirement, and latency constraint. So we can put all of this together and came out with some, some techniques that will help us to give indicator where we can allocate resources better. From the practical point of view, this is like the architecture of our implementation. So we'll have something what we call as the edge computer. So edge computer, we design it in the form of Raspberry Pi or NVIDIA type of single board computer, where we install the machine learning algorithm, which is of smaller size. Okay, so that's why we rely on the library of light, TensorFlow Lite, for the application of the edge computer. Why? Because this edge computer will rely on battery, which is shared with the drone. Okay, we don't want this edge computer to consume too much battery, and then the drone can only fly for 5 minutes without being able to gather all the necessary information from the field. And then we have the full versions of the algorithm at the cloud. And we know that the cloud is connected to the electricity, to the grid, so we are not worried too much about the battery supply. And we want to have like comprehensive model here because then we need like certain accuracy for further analysis. And this is like some of the practical or field findings. So we are not just looking at the guidance principles from the information theory analysis, but we also carry out some findings from the field. We look at how the TensorFlow Lite and TensorFlow compare in terms of accuracy. We look at the battery level, and we look at the sort of like the delay that is apparent by comparing between local and cloud. Yeah, and we did not like a point of switching. So we know that we may not be able to rely on a local computation so much over the time. So we need to know like the optimal point where we need to switch between local computations and cloud computation. Obviously, if we have unlimited resources, we want to do local computation as much as possible because that will give us the low latency capability of data capture. But because obviously the resources are pretty much constrained, then we'll have a problem on the local computations alone. Yeah. Okay, maybe I'm going to skip this. This is just another example of putting like the algorithms, putting the AI algorithms within the system. So apart from the data capture, we can actually do more algorithm to analyze the content of the data. And this is like an example of the of the detection. This is taken from the video recorded from YouTube, but we are not analyzing offline. We are analyzing close to real time. We download that YouTube and we use the drone to stream this. Yeah, in addition to detect the occurrence of the disaster. Because again, we cannot replicate the actual events of the disaster. So obviously we have to do something to represent this detection capability. And all of this display was actually observed from the terminal, yeah, from the terminal that is connected to the base station. Another example is this. So this was taken from the top of the drone. This was actually three of my researchers, which carry out the detection. So it's actually quite accurate and quite of low latency as well. So obviously with 5G we want something in the order of sub-millisecond, right? But for some of the applications like this type of detection, perhaps we can still tolerate if we have delay for a number of seconds, right? So it's not affecting too much in that sense. But when we talk about control, for example, like robot control or drone control, then we need something that is quite precise, because otherwise it's going to be quite dangerous to the users of the autonomous devices. Okay, this is like some of the snapshot we do for the experimentation. So we did both experiments for the drone and also for the robot as well, and we carry out some end user driven AI applications. So the application that we do is we identify the species of the tree. We do also the identification of deadwood, burrow, and so on and so forth, because that can indicate certain diversity within the forest itself. Yeah. So when when we are doing this experiment, we are not doing it for the sake of technology itself, but also for the sake of the end user-oriented requirement, which in this case is the forestry stakeholders. Okay, given that, I always say to my researchers that, okay, we know that this is multidisciplinary project. We know that we need to produce something that is demonstrable to the government, but we should use this opportunity not just to do that type of applied research, but also research that will benefit our technology itself. And I think it works quite well. We managed to have like some two developments from the perspective of coexistence of new radio, 5G new radio, and Wi-Fi, and the other one is on the ability of interference suppression in NOMA-based system. Yeah. Okay, I think the last part, which I'm going to maybe a little bit share to the audience here, is the part on the molecular communications. So in molecular communications, we depart away from the utilization of electromagnetics, radio signals to carry out the signals, to carry out the informations. So in this case, we use what we call as the chemical particles. Okay, so we say that the chemical particles will move from one terminal to another, and they will move with a certain trajectory. They will move with a certain concentrations, and based upon the trajectory and concentration, we can detect and perhaps make decoding on the type of the information that is being transmitted. Okay, so the information can be modulated. The modulation here is not QAM or QPSK, but the modulations is in the form of concentration modulation. So the different level of concentrations of the chemical particles will indicate different level of informations. Modulation can also be based on the type, meaning like different types of chemical particles can be utilized to indicate a different type of messages. And then finally, we have timing modulation, which means depending on the timing interval, different chemical signals may represent different messages. Yeah. So these have a lot of applications, in particular the healthcare, industrial applications. So I think like our dream when we did this research is in the next 100 or 200 years, we can actually design a biologically friendly robot of nano size, which can communicate using molecular communication here, and they can actually be injected directly to human being to carry out certain drug treatment possibility. For example, like we can put that nano robot to target maybe like a cancer cell, and then they can do the certain collaborations between themselves and target directly the cancer cell for treatment. So this was like the dream when we start research around this space. So what we did so far to make that progress is it was quite simple prototype. Okay, so the prototype was actually costing us together around like 500 pounds sterling. So we have like a single board computer, and then we have also like the spray, and then we have some controller that measure the concentrations of the chemicals that we want to release. And since this was actually done in the UK, I think alcohol in the UK was quite cheap, I think. So we use alcohol as the chemical types for the experiment. Yeah. Okay. And then we carry out like the characterizations. We try to send like a text messages from one terminal to another terminal, and we try to make some decoding. So. And this is not just something like we play for fun. It's something that is moving towards the standardization. So you can check out the IEEE 1906.1. So this is one of the standardization effort for these molecular communications. What's the problem? The problem is not noisy information. The problem is the timing when the information arrive. So rather than having ordered timings, the information may arrive at completely different order. And this is what we call as the transposition errors. And the problem in molecular communication is mostly dominated by the transposition error, bits that exchange rather than noisy bits. Yeah. And the other problem is because of that, transposition errors, we cannot send high data rate signals. So the rates that we have managed to obtain within this prototype is only 0.3 bits per second. So it's very, very, very low. Yeah. very, very low. But again, this was just like a starting point. I'm sure the ones that are continuing doing research in this area, they will make some advance and progresses, and there are also effort around making these devices smaller and smaller, as well as working with people from biomedical engineering to make sure that some of these device replica can be applied in the context of maybe biological processor and so on and so forth. Yeah. Okay, so this will be like a summary. Again, as I mentioned earlier, I was actually not continuing this for maybe 3 years, 3 years already, but I will still be happy to continue this if there are certain interests from other people. So if any of you will be interested in looking at this further, being one of the pioneers in a lot of the techniques that will emerge from the molecular communications, then I will be happy to maybe discuss this further. Yeah. Okay, I think that will conclude my talk. So we'll be happy to have maybe more detailed discussions with the audience. So I will
Yeah,
turn this back to Asif. Thank you.
thank you, Professor Taufik. Very, very, very inspiring presentations, and I noticed there are some topics that are very familiar with us in the Research Center for Telecommunications, BRIN. And you mentioned also about the molecular communication. I believe one of our researcher was involved in this research in Germany.
Okay,
Mas
that's good.
Indra, maybe. Mas Indra is here, Mas Indra? Yeah, I think he's been involved in some time ago in this research. Maybe, maybe.
In Nuremberg, yeah? Is it like Nuremberg, the university, Robert Schober?
Mas Indra, I think, was in TU Braunschweig.
Oh, Braunschweig. Okay, okay.
Yeah.
Braunschweig
Okay.
with Professor Kuhner.
Yeah, I think the topic is molecular communications. Is that correct, Mas Priyo? Maybe, yeah.
Yeah.
Okay,
Yeah,
that's good,
yeah.
yeah. That's good, yeah.
As far as I know, he are working in a how to communicate using a human tissue, communication on human tissue.
Oh, right. Okay. I see.
Oh,
Yeah.
yeah. Okay. Okay, so that's so there are many questions from my side, but is there any questions from audience before I give my questions, Professor Taufik? Please raise your hand, or you can also write your questions in chat. Is there any questions in the chat?
Yes, I think I have a.
Okay, Mas Priyo, you want to ask questions, please?
I have a question. Yes.
Okay.
Thank you, Professor. Let me introduce myself. My name is Priyo Hartono. I was also working in Germany before, but took my PhD, but not finished. And then Asif told me about that. You are searching for some people to work in your university. I saw that in the system, it's quite a huge systems. I mean, in my case, I was working in more like RF device, building create simulation and then fabrication, and then put the device itself and then measure it. And if I'm not mistaken, you said that in the one of the system itself, when you are using the Raspberry Pi, you are using the TensorFlow library. But you said that earlier that you need to create another library, so it will eliminating or the latency itself, or the TensorFlow could be coexist with the library that you are creating. That's the first question. Then the second one, as I said earlier, about this is quite huge system. Which part that you are, let's just say, if I attend your group, or just collaborate with your group, and what kind of which part that you are pursuing first, and then let's just say, or you're just using some available sensors what that available or
Yeah.
created by your own.
Yeah.
That's
Okay, thank you, Mas Priyo. So I think all in all, when we did research, we have to actually define like the novelty, right? So the novelty will actually translate into the directions what we are trying to do. For example, like when I was actually not putting everything on the slides, but uh, because I have like a quite a number of researchers, so they are actually working on different things together, and obviously at the end of the day we have to put it together. So the one that I put on the slide, the researcher was working on the collaborations between edge and cloud. So I think for him, it's important to see like the different trade-off between allocating resources to the cloud and different trade-off in allocating the resources to the edge computer. And then what is the implications beyond that? So the implications will be around the resources, and then finding the optimal point, finding the optimal resource allocation, and so on and so forth. So that is one possibility. Another possibility is, I think one of the other researchers is doing is, she was actually doing uh, the local library development of the machine learning applications which we try to develop in the forest. It was not on the slide, but it was on one of our publications where because like we talk about the unavailability of connectivity sometimes, or intermittent connectivity in the forest. Obviously, if you have to rely on a cloud library or cloud-based library, which are actually available in across different application in your mobile devices, I'm sure that you can download one of the application and use it, right? But that that actually deviates from the purpose of the application in the forest, because in the forest we are not expecting a continuous connectivity. We may have intermittent connectivity. So in that case, I was asking actually her to follow on the path of developing the local library for the machine learning task. And not only that, I also asked her to actually do a kind of buffering, because we know that we will capture a lot of data from the field, but we may not be able to offload the data directly to the permanent storage like cloud, right? So in that case, we need like somewhere in between to buffer the data.
Buffer.
So obviously, in that case, the novelty would lie on this data management side. So I think for me, I think at the moment, like, because obviously, as I mentioned, as you can notice perhaps from my slides, that I was not really focusing on one particular thing, but I have like the big umbrella of CPS and computational intelligence. So I'm pretty much working around that. Uh, a specific direction will depend on whoever is going to do certain things. For example, like I'm expecting to have a number of projects in the next couple of months, actually, and I have one working on digital healthcare. Okay, digital healthcare. So we look at the possibility of analyzing the risk of heart diseases close to real time. But again, my focus is more on the data processing side, not on the medical domain side, right?
Yeah.
And then there is also one possible projects which we are going to use drone to carry out monitoring. So hopefully that projects will be signed off by sometimes this month. We may also have another projects still waiting for the confirmations, but we may be expecting something around IoT for aquaculture. So these are like the three main things. But obviously, I'm quite flexible this time around. So I'm always curious with with something that challenge me. Okay, so anything that is interesting, that anything that does not have straightforward answer is something that I will be interested in having further discussion.
Thanks. Thank you for that.
Okay, thank you. There is another person raising hand, Pak Serandi. Pak Serandi?
Yes.
Serandi, yeah.
Yes.
Silahkan, Pak. Please give
Okay,
your
thank
question.
you. Should I turn on my camera?
Okay, yeah.
Thank you for the opportunity. I would like to introduce myself. My name is Sarani. I'm from the research group of advanced network protocol. One of my research interests is like in how to use explore the communication system for disaster management purpose. As far as I know is that if you deal with the disaster thing, there's like a before disaster and post disaster, something like that. And we know that these two conditions may have very, very subtle characteristics. For example, that before disaster, you may deal with like, large transfer of data, high speed, and then you have very stable infrastructure. While after disaster, you may have like very limited infrastructure, which means that, in my opinion, it would result in different types of computations resource. So is there any kind of like effort or research effort how to kind of shifting the computations of the communication resource on the fly, right? Because probably before a disaster, we collect data as much as possible. And after disaster, how can we reach more people? Probably we don't need to very high-speed communication, but reach more people, large coverage, small chunk of data, but very low latency, so something like that. So is there any kind of research that including like in the physical layer or probably in the technology itself? Thank you.
Okay, thank you Pak Senandi. Jadi, so I think disaster management research is huge by itself, right? So even like as you rightly say that the pre and post disaster management could have like different possibility in terms of research approach. Let's say when I think your question is about like what's happened, let's say after disaster, and I think that research will be something let's say we utilize like technology such as UAV to carry out rescue on. The big questions will be not just about the communications, but also the computational resources like the battery lifetime, because obviously all of these devices will rely on battery, and they have like certain lifetime, right? So I think the UAV that I use, they can only, let's say, only stay for flight for 30 minutes to 1 hour, so it's not long enough. So I think one of the research direction in that, as far as I'm aware of, is on the joint resource allocations of communication, control, and also the flight path. Okay, because when we talk about UAV, it's not just monitoring or observation, but also the path, right? And that path will also have impact on the communication requirement, and will also have impact on the battery life saving. And then when we talk about, I think there is also research around utilizing UAV for access point. Okay, to extend the capability of communication. So again, utilizing that capability of UAV will also requires detections of communication presence, right? Because like you don't want your UAV to fly in an area where there is no one there, because otherwise you go there, but it will waste energy and resources by going there. So I think there are a couple of directions there. One is on the joint resource allocations for communication, control, computations, plus the flight path. The other one is looking at utilizing UAV as a access point extender, let's say. Okay, and I'm sure that there are these two maybe people will think that okay, it's only two directions. No, but within these two, there are a lot of things. For example, utilizing what kind of protocols that are of low latency, utilizing what kind of coding schemes that will save the delay of exchanging the information. If you talk about a certain rescue effort that leverage upon the swarm of drones, for example, then the low latency is getting more critical, because you are not only communicating for the sake of communicating, but also you are communicating along the fly. You are trying to accomplish the tasks together within that flight mission. So there are plenty of things, I think, quite open. I think the other thing, perhaps inspired not from the technical point of view, but inspired from the regulation point of view, is at least in the UK, I'm aware that we cannot fly the drone without certain license or without certain permissions of flying drone, and there are certain regulation associated with drones. So in that case, sometimes the way we develop the solution is we need to also obey the regulations, which can be quite tricky. For example, like when we do these 5G connections from the drone to the base stations, we cannot use the commercial license to do that because drone is classified as airborne vehicles. And airborne vehicles, we cannot use our phone, right? And in that case, it presents us with challenges on utilizing the spectrum without breaking the regulations of spectrum licensing. Yeah, there are a lot of things like open problems. You can make approach from the technology point of view, or you can also utilize the approach from what we find from practice. Because I think what we find from practice is very important, especially if we want to make sure that our findings will have impact, right? I think part of the idea why some of the innovations will find a long way to the market or to the societies because they are developed pretty much independent from what are the challenges in practice. So I think it will be quite interesting to see like what's really happening in Indonesia in terms of disaster management, and then map that out and design a solution that address those challenges. So even like we make slow progress, but if it really addresses the challenges directly on the field, I think that will give a bit more, pathway for successful interaction between us as a researcher and the one who is doing that in practice.
Yeah, okay, thank you. Yeah, because my question is really kind of driven by this extensive use of AI and also cloud-based. While we know that this type of infrastructure really exists in the peacetime where the infrastructure is intact. However, in the after disaster especially, we don't have such infrastructure. It means that okay, can we do AI, or do we have to change our paradigm of computation? Means that we usually normally do that in cloud-based, and then we have to save that into something like that. That's what the driving point.
Yes.
I ask these questions.
Yes, we can. And actually, one of the direction in AI is what we call as a tiny ML.
Oh.
And that tiny ML, the idea is a part of the idea was actually implemented in one of my projects where we implement the light versions of the full model in the edge computer. So that edge computer can actually be carried by the UAV in that case, yeah, and they are actually sharing the same battery resources as the drone. So it's possible, but obviously we will not be as good as the full version. But still, there is a level of intelligence we can equip. And in terms of communications, we can create like more like ad hoc communications between the operating devices. So that ad hoc communication can utilize a spectrum that is reserved for disaster events. I believe there are certain spectrum reserved for that. At a very simple case, we can always use the what do you call it, the ISM band, right? The one that is used for Wi-Fi and so on and so forth. So it's a possible. So tiny ML and ad hoc networking, and maybe utilizing a specific communication channel which is coming from disaster reserve spectrum. I haven't checked the Indonesian context, but we do have certain spectrum reserve in the UK, and that is actually being managed as a cognitive radio resource allocation. So people like authorized agency can actually request that particular spectrum on the fly to facilitate the communication during the emergency situation.
Yeah, actually, I'm looking for my PhD first, within this kind of topic.
Okay.
So yeah. So if you don't mind, if if there's any opportunity.
Yeah, sure. We can have discussion. So I'm not sure what Asif mentioned, but I have like a plan in September to visit Bandung. So hopefully, if we got a chance, I can BRIN.
Okay, thank you.
Actually, Pak Surendi is in Serpong or Bandung?
Serpong, Pak.
Oh, Serpong.
Yeah.
So it's quite close. We are quite close. So
so we can meet anytime, right?
Yeah, sure.
Yeah. Okay, so we actually ran out of time. So is there any other questions from audience? Yeah, okay. So, yeah, I think maybe that's all for the discussion part because this is scheduled until 11:30, but that's okay. I think this is very interesting discussion and very interesting webinar. And hopefully this is not the last time we will have Professor Taufik here. And also we know that, mentioned by Professor Taufik, next month you will visit Bandung. Do you have the certain date already?
Yeah, I think it's 19 and 20, I think. And in
19
one of
and
the days
20.
I will give a talk in ITB, but maybe on the other day I can visit BRIN, maybe.
Okay, 19 or 20 September. Okay, so yeah, we can schedule maybe Pak Ruli can schedule some event with Professor Taufik, or maybe just ngopi-ngopi bareng. Yeah, that's okay.
Yeah, it's possible. We'll invite you to come and visit our lab. Actually, it's possible. Welcome.
That will be great.
Okay.
Thank you. Yeah, that
Yeah,
will be
thank
great.
you.
Okay, thank you very much. And yeah, with that, I will hand over it to Ms. Christine. Thank you very much for your attention.
Thank you, Bapak Asif Aminul Fatan, PhD, and Professor Taufik Asihari for being us to very productive session today. So, ladies and gentlemen, we are currently in the closing session. We would like to remind you that link to the attendance report form is now available and active. The link has been embedded in the chat column. On behalf of the committee in charge, we would like to express our apologies we made during the event. Thank you for your active participation today and have a great rest of your day. See you later. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you very much.
Thank you.
Thank you, Prof.
Terima kasih.
Thank you, Asif. Thank you all.
Thank you.
Thank you.